Hi, welcome to lesson 19a, area under the curve. The goal for today's lesson is to calculate the area between functions and the x-axis over some interval. So we've already established over past lessons that the first principle's definition of an integral is to find the area under a curve between two endpoints of some function and finding the area between the curve and the x-axis. So when we say area under a curve, we're basically talking between the function and the x-axis. The x-axis, however, and this is a little bit of insight into perhaps the next lesson, that function is actually, the x-axis is actually, the equation of it is y equals 0. Okay, so we might see where we're going with this eventually. So when we're finding the area under a curve, we're finding the definite integral from a to b of f of x dx. And that can be evaluated as uppercase f of x between a and b, and that just tells us it's uppercase f of b minus uppercase f of a. Alright, so let's take a quick example of, a quick look at an example of finding the area under a curve. Let's find the area under a curve of the function of sine x with respect to x from pi to 2 pi. Okay, so following this definition of the definite integral, the area under a curve, well, we know first of all that the function sine x looks something like this. Here's pi by 2, here's pi, there's 3 pi by 2, and here's 2 pi. So we're looking for this area here from pi to 2 pi. Okay, so we take the integral of this. Well, remember that if you take the derivative of cosine x, then that gives us negative sine x. Well, this is positive sine x, so we have to make sure that when we go back from here to here to get the antiderivative, we include a negative in with the cosine. So this is going to give us negative cosine x evaluated from pi to 2 pi. And when we do that, we got negative cosine of 2 pi minus negative cosine of pi. Well, then a quick sketch of cosine would never hurt. So cosine looks something similar to that. Here's pi by 2, here's pi, 3 pi by 2, and there is 2 pi. So we're going from basically pi to 2 pi. So here's negative 1, here's positive 1. So the cosine of 2 pi is 1, so it's negative 1 minus negative, and cosine of pi is negative 1 already, negative 1. So you got negative 1 minus, and then here's positive 1, and so that gives us negative 2 as the final answer. So that's all fine and good. If we were looking at just the definite integral of sine x between pi and 2 pi, negative 2 is just fine. However, we're looking for the area under the curve, or the area between the curve of sine x and the x-axis, which is y equals 0. So because we're looking for an area, we have to make sure that that's positive. So in order to do that, we need to then take the absolute value of this to give us the value of 2. Okay, because we know areas are positive, just because this this loop, I guess, this arc of the sine function is below the x-axis, just because it's below, it doesn't mean that that area should be negative. Okay, so the area is positive, that's why we put the absolute value. Okay, so I'm just going to show you now on the calculator how to do this. We're going to do this in class tomorrow. So we're going to use this GDC, and in order to find this integral, we're going to go to Math, and then we're going to go down to function interval, or integral, I guess, and press enter. Then we're going to put in the values that we want. So we're going to put in pi, which is second, and that little caret, and then we go up to, sorry, I guess you didn't see what I was pointing at, second and that caret to give me pi. And then we're going to go to 2 pi, so put in 2, and then again second and that caret for 2 pi, and then I arrow over and I want the sign of x, which is that button here, and then with respect to x, there. Okay, so when we do this, we get a value of -2, just like we calculated. Now, in order to get the absolute value in here, what we'll do now is we'll do the same sort of thing, but so we go to Math again, go down here, so we'll do pi to 2 pi again. Now this time what we're going to do is we're going to put in the absolute value. So absolute value, we're going to press Math and go over to num, I guess number, and the very first choice is abs, which is absolute value. So you enter that, and then now we see that we have the absolute brackets, absolute value brackets around there. Then we put in sign x with respect to x, press enter, and there we get +2. Okay, so we've taken the absolute value of that before we take the integral. Now the same thing would occur again if we were to do absolute value first and then do the integral. Now we're going to go pi to 2 pi of sine x with respect to x, and we get a value of 2. So whether you do the absolute value around the whole integral or put the absolute value around the function itself, we're still going to get a value of 2. Okay, so that is that for area under the curve. So please take a look at the examples in the textbook, and then we're going to be looking at a few examples in class, and then you can work on the practice questions during class after we finish the examples. So thanks for watching, and we'll see you in class.